Hello and welcome to this session on machine learning. In this session, we are going to discuss about cost function. So what is a cost function? So cost function measures the performance of a machine learning model for a given data set. So cost function is a evaluation matrix which is used in machine learning models. So cost function is a measure of how wrong the model is in terms of its ability to estimate the relationship between x and y. So how wrong the model is. So here basically cost function can compute the errors or the residuals within the model. So when we are using this cost function, it can give us it can tell us how wrong the model is in terms of its ability to figure out the relationship between independent and dependent variable. So this is typically expressed as a difference or distance between the predicted value and the actual value. So here to take an example and to understand this cost function, imagine there is a 4-year-old sitting by a fire to keep himself warm, but not knowing the danger of fire. So he puts his finger into it and gets burned. So he has no idea about the fire. So just a 4-year-old kid. So he just puts his finger in the fire and gets his finger burned. So next time he sits by the fire, he doesn't get burned because he sits too close, but he gets hot. So he gets too hot. Third time he sits by the fire, he finds the distance that keeps him warm without exposing him to any danger. In other words, through the experience and feedback, the kid learns the optimal distance to sit from the fire. So the heat from the fire in this example act as a cost function. So here from the heat, the kid is learning like what is the right way to reduce that cost function. So here basically the major goal of any machine learning model is to reduce the cost function, that is to reduce the errors. So if you reduce the cost function, thereby the errors will also get reduced within the model. So here within this example, the heat from the fire is a cost function and the kid is trying to reduce that heat uh, which is there in the fire. So this is what is the cost function. So cost function quantifies the error between predicted value and the expected value and presents it in the form of a single real number. So depending on the problem, cost function can be formed in many different ways. So the purpose of cost function is to be either minimize the error, or in some cases we also maximize the cost function values. So minimize means this will return a value which is actually the loss or error value. So whenever we have loss or error values, we have to minimize that. So the goal is to find the values of model parameters for which the cost function return as small number as possible here. So we have to minimize the errors in lot of cases. So based on the problem statement, we have to use different strategies. The other one is maximizing. So here the value it yields is nothing but a reward. So the goal is to find a value of model parameter which return number is as large as possible. So here we have to find a larger value in case of certain models where the cost function might be a positive reward. So these are the two aspects of cost function. Now here basically to find out the error within a model or to compute the cost value in regression, we have mean squared error. So this mean squared error tells you how close a regression line is to a set of data points. It does this by taking the distance from the points to the regression line and squaring them up. So this squaring is necessary to remove any negative signs here. So it also gives more weight to larger difference. So it's called the mean squared error as we are finding the average of set of errors. So here error, as we already know, error can be defined as y minus y predicted. So that is the observed minus the predicted values. So mean of square of that value is mean squared error. So this is the formula. MSE equals 1 by n of summation of y minus y pred whole square. So here I is nothing but index of the sample. So as many values will be there, that many y values we have to take, and the predicted value for the same, and n is the number of samples in the data set. So the smaller the mean squared error, the closer you are to finding the line of best fit. So here as the mean squared error is smaller, then we are finding out a much better best fit line. So this is with respect to regression, like just understanding how a mean squared error is computed. Similarly, there is root mean squared error. Root mean squared error is like same mean squared error. We just take the root here. That is RMSE is a quadratic scoring rule that also measures the average magnitude of the error. So here it's the square root of the average of squared difference between prediction and actual observation. So RMSE is nothing but root of the mean squared error value. Here, if you look it in the graph, like this is how it looks like. Suppose we take the error values, so the graph will be smooth here. So this is the error values which will be defined by mean squared error. The other one is mean absolute error. This is one more measurement which is there. So this is a regression metric which measures the average magnitude of errors in a group of predictions without considering their directions. So in other words, it's a mean of absolute difference among prediction and expected value. So it's just mean of absolute difference. It is y pred minus y. We have to take the absolute value of that. So this is the formula given for mean absolute error. If we find out the errors for all the samples within a data set, like all the sample values, it will look something like this. That is, the graph will be like a steep graph. This is how a mean absolute error will look like. So these are both different evaluation metrics which is there. We can either use mean squared error or mean absolute error to find out the errors within the model, to see the model performance, to measure the model performance. So here one more thing to know is like mean absolute error is less than root mean square error if the sample size goes up. Like when the sample size goes up, the value of mean absolute error will be less than the RMSE values. Also, one other thing is like mean absolute error is less biased for higher values. Mean squared error is highly biased for higher values. So this is one important like difference. But actually, like we can use any of this error method to compute. Like both are different computing method to understand or to see what is the amount of error which is there, which is accumulated within the model. So here basically to see how good the model is performing, we can either use mean squared error, root mean squared error, or mean absolute error techniques. So this is all about cost function. So the major goal of a regression model is to reduce the cost function. So once it is able to reduce the cost function, that means the model is much more like the model is very much accurate. So accuracy will also be increasing once we are able to reduce the error values. So that's where like cost function is a very important measure which can tell us like how our model is fitting to the data. So that's where like for evaluation metrics we use few of these techniques, that is mean squared error, root mean square error, and mean absolute error. So this is all for this session. Thank you.